In this example, we're going to find the region enclosed by y equals e to the negative x, y equals 0, which is the x-axis, and x equals -1, which is this vertical line right here. Now, when we find that enclosed region, that's this right here that I have shaded, and then we need to rotate that about the line x equals 1. So this is my curve, y equals e to the negative x. Here's my region that I want to rotate. Here's x equals 1 that we're going to rotate it around. So that's going to be the center, and this is going to rotate around this way. Now, the shape that we're going to get, hopefully you can follow what I did here. When we rotate that, we're going to have two sections of that volume. When I rotate this piece right here around the line x equals 1, that's going to form this cylinder that's in here, or a cylinder shape, I should say. And then, so that's this part right here. But then when this goes and rotates around, that's going to give us this bowl shape on the top part of this volume. And here's our line x equals 1 that we rotated around. So this right here is the curve e to the negative x when it's rotated. Now, I considered doing this using the disc or washer method because that's my personal preference, but I noticed if I was going to use that, I would have to break this solid up into two pieces and have two intervals, because if I look at the bottom part and I take a slice, that's going to give me something different than if I look at the top part and take a slice. So I would have to split that up into two pieces. So rather than worrying about that, I decided to end up using cylindrical shells. So if you imagine you have one shell, here's our line that comes up in the middle, x equals 1. If I slice it and unroll it, we have a rectangle. The height of that rectangle is going to be e to the negative x, right? So when we rotate this around, the height is going to be e to the negative x. This here is empty space. Now, the length of the rectangle is going to be the circumference. So when we slice it and unroll it, the length is going to be this right here. So we're going to have 2 pi, and then the radius is going to be the distance between the x value and the line x equals 1. Now, because we want to find the distance between x and 1, I'm using absolute values here. When we're using the shell method, we have 2 pi r. That's our circumference, that's the length, and then the height. Usually, in most cases, the height of that rectangle is the function. However, there are special cases where you have to take into consideration, such as if you're trying to find the height and you're dealing with something between two curves. In this case, our height is the function, so we don't have to worry about that special case. And since we're doing this on the interval from 0 to -1, those are going to be my lower and my upper limits. So after giving it some thought and making sure that these can be removed, I looked at what the radius would be when I'm just over here. This is our region, and we're only using negative numbers from here to here. So if I want to find the distance from here to here, I would take 1 and I would subtract my value of x. Because my value of x is negative, I would have 1 minus a negative number, which would end up adding x because of the double negative, which would work because wherever the x is here, I want this distance of 1 plus that positive value of x. Because this is going to be a negative value, I know that I'm going to take 1 plus because I'll have a double negative here. So here's the length, and then here's our height. So when we take 2 pi and multiply it by both of these, I actually integrated this part while I was distributing because this part's easy. The antiderivative of e to the negative x is e to the negative x divided by the derivative of negative x, which is -1. So this here is the antiderivative of this. This part here, we still need to integrate. So I'm going to subtract the integral of xe to the negative x, and I still am keeping that 2 pi over here. I'm going to keep carrying that through. And I'm still keeping that I want to evaluate this from -1 to 0. When we go to integrate this, we're going to have to use integration by parts, and that's what we get in here. Now you have to be careful because there's a lot of double negatives going on. So make sure you write everything out and then try to simplify. I found out the hard way that I started trying to do all the double negatives in my head and I ended up making mistakes. So I ended up rewriting them all out. So I'm still carrying down that 2 pi. This is already integrated, and I'm going to subtract what I get when I use integration by parts. This is what we get for integration by parts. And then we evaluate from -1 to 0. Because I have this negative and this negative, I have a negative e to the negative x plus e to the negative x. So these drop out. And then this negative and this negative make a positive xe to the negative x. And then, of course, I'm going to keep carrying down my 2 pi. So now when we evaluate this from -1 to 0, when I plug in a 0 to this, it's just 0. When I plug in -1 and simplify this, again, we get a couple of double negatives, so be careful. Remember, the first part was 0, and then we subtract whatever we get when we plug in -1. So that would give us a double negative here, and then when we plug in -1 up here, that's also going to give us a double negative. So what we end up getting when we plug in -1 is 2 pi e.